Okay, hi everybody. So we're going to quickly do a little video here about simplifying radicals. And so what I've got here is the square root of 32 multiplied by the square root of 2. And I am going to I'm going to take a little bit of a time here to make this out to be a slightly more complicated question than it really is, just to illustrate some of the relationships that there are that exist here and how you might approach these in a more general sense here. So first of all, when I've got the square root of 32 multiplied by the square root of 2, remember that what I can do here is multiply the radicands together, okay? So I can make this the square root of 64. Now, I know, you know, that the answer to that is 8, okay? The square root of 64 is 8. But now what I want to do here is I want to take a quick look at how we might approach that, or remind you of how you might have approached that earlier, um, to get that answer there using some tools that you would have I've talked about in a much earlier class here. Normally, what I would do with my students here is I would talk to them about taking that 64 there and breaking it into its prime factors, right? So we've got the 64, and I know that 64 is 32 times 2. I mean, we just looked at that. And I know that 32 is 16 times 2, and there's that other times 2 from above. And I know that 16 is going to be 8 times 2, and then there's the times 2 from above. And then I happen to know that 8 is 2 times 2 times 2, and then I've still got 2 times 2 times 2. Now, I've got it all written out as prime factors, and maybe you wouldn't do that, or maybe you could get to that quicker. It doesn't really matter here. Um, it's just that I'm trying to show you that if the question's a little bit more complicated, this is something you can do. And remember that what a square root does is it takes pairs of factors, and there's a reason why it does this, but just to give you kind of the mechanism here, it takes pairs of factors underneath the radical sign in the radicand, and for each one of those, it spits out a factor, a single factor, to represent that pair. So 2 times 2 times 2 is my final answer. When I put that together, I get 8. Anyway, so I just wanted to a couple things to make sure that you understood here is that when you're multiplying radicals together, you're going to multiply the radicands. Now that's assuming that it's the same type of a roots, like square root by square root, cube root by cube root, and so on. And then one tool that you can use is to rewrite that radicand in terms of its prime factors, and then pull out pairs if it's a square root, cubes if it's a cube root, and so on.